Good afternoon in 5 seconds. Good afternoon. We're at the lathe, and we've been making these little buttons. This is what it looks like when it's done. They're coming out quite nice, except all lathe parts seem to have a little pip. And I know I can probably go in there and mess around with programming, but it's not worth it. So we'll handle that a different way. Good morning, guys. So yeah, we're at the lathe. Haas TL1. See if I can give you the overview. Good morning, good morning. So we're making these little guys. And I have to say, once I got got everything dialed. Hi, Chris. Good morning. Once I got everything dialed, they started really looking nice. But these are this is for an in-house application. You'll see it soon on the feed. And this is the Op 1 right off of the stock. You can see the cutoff pip. And then we're just doing Op 2 in this little collet chuck, which is this guy here. So this is a Marry tool. Give them a plug. I love these guys. It's a Marry tool collet chuck with a straight shank, and there's a little piece of shim stock there, so we're not hard on hard. And this works great. This looks awesome. And I have to give a plug to this Sanchuli 3-jaw. This happens to be what was on the machine this morning. And boy, howdy, it's holding concentricity amazingly well. So this whole setup is good to I don't know, 0.002 or something. That's what it looks like, maybe a little less. So anyway, we throw that in there and we do the Op 2, and then I'm going to decide if I'm going to get super fancy on that surface to get rid of the little pip. I might grind it. What do you think? Should I grind it? Anyway, that goes to a different department, and you'll see where that gets used in a future post. But those are just, in-house parts. So we're on the TL1. We're running a program that was not written with CAM. It's written on the machine using the conversational, and then you could save the conversational chunks and then run the program. And then I go in and I add the coolant on here, and I add the coolant off, and move off to a safe space and an M30 here. So combination of conversational and a little tiny bit of G-code hacking to do what I need to do this morning. So you guys, if you're regulars, you've never seen me at the lathe, but it's true. I'm at the lathe. There's the lathe tools. And there you go. So right now here in the great state of New Hampshire, it is raining. Can I do that? Oh, I could do that. Look at that. It's raining out there. And I am very happy to be in the shop. Oh, I didn't know I can go super wide angle. That's excellent. So, good morning. I hope you have a day in the shop too. Couple of things going on today. I got to get those little buttons done. Those will be done very soon. And I will get those to the other department. And then over here in the Department of Grinders department. Oh, Oh, Adam, good morning. We were just at the lathe. I don't know if you saw, but we'll get back to that later. So back in the grinding department, things are quiet and they're going to get busy this afternoon. We've got to get going on stone production because the orders won't keep. So that's what's going to happen this afternoon. Stone production on the new Okamoto grinder. Okay, and that's going to be very exciting because we have to adjust our recipe. Welcome, Hamid. We have to adjust our recipe for the new grinder, which I don't think is going to be terribly hard because we have a recipe that works super well, and now we just have to translate it. And yes, it's not a trivial recipe because the stones are weird. And we talked about that before, but I could talk about it again. The latest success on the grinder was this ridiculous thing, which you can tell is like a mirror. So this is a piece of A2 tool steel that I got a while back from Adam the machinist, who is here with us this morning. And I just use it. I'll show you the other side. I use it as a demo for the PFG Stones. What we do is we take a carbide scriber and we scribe a scratch. You can see some of the scratches. We scribe a scratch in there, and then we take down the scratch, the burr, with the stones, and then it disappears. And you can't feel it anymore. And the little round scratches is when we take out a factory stone and apply it to the surface, and of course that's what it does to it. So I threw this guy into the grinder just as a process experiment, and it is stunning how good it came out. Let me wipe that off. I mean, literally, fingerprints are annoying with this surface. It came out at a measured RA of 1.95, call it 2, RA, 2 micro inches. Sorry for metric guys. So very happy with that. And that, I was asked a lot about what stone was being used for that. And that was a white wheel. So this is the wheel that came with the grinder, okay? Nothing special. And I cannot find a marking on it. It's probably under the hub, but it's just a generic white wheel. I think it's 46, and I think it's probably an H or an I, but nothing special. I figured I'd use it up while I explore the grinder capabilities, and that did the chuck. And that has done a bunch of experiments, which you've seen, and the experiments have come out just super. So very, very happy with that. And of course, ironically, the PFG stones are used in the manufacture of PFG stones. So go figure. This is the surface roughness meter. I bought this off eBay, and the thing was used. If it was used at all, I can't tell. So I thought I got a screaming good deal on that guy. And that comes with a reference calibration standard, and you test that, and it gets you sorted out. So one of the things I'm going to do, I don't think I have time to do it on this live, but I'm going to run this on a piece of on an optical flat that I have upstairs that's big enough, and see what an optical flat registers on here, because I have no idea. Because this thing, while this is not optically, I mean, the camera is a little more helpful to make it look like a mirror, but you can tell it's not exactly, optical quality mirror. I don't know if we can. Yeah, you can see that the far side of the of the scale starts fuzzing out, where that wouldn't happen in a mirror, but it's damn close. So yeah, super happy with that. So the grinder status is everything's working great. I have gone through the semi-automatic mode. That's pretty well completely understood and has been useful. We've gotten into automatic dressing. So this is the dresser on the left side of the chuck, and the X position that this sits at is sort of a built-in hardware thing. And we have a straight diamond that's tilted 11 degrees, presumably, in the back. And then we have these two really cool diamonds. I'd never seen them before, that are sort of rectangular. And they're pointing up at 45 degrees. Hey, there's John. Good morning. Good afternoon. And so the wheel can come in and dress its bottom on this diamond, and then come over here and do its sides on these two diamonds. So that gets calibrated up. So I have not yet done a form dress on here where the wheel, literally you can dial in whatever shape you want on the wheel and then go do a plunge grind and it'll put that shape on the part. But that's coming. We'll get there. Right now it's not terribly important, but I do have it straight dressing on the back wheel, and that's part of the reason we were able to get hey, you're right, that's a little hot there, John. Hey, yeah, I called you before, John, and I was going to ask you if you wanted to stop by and chat, so let me know if you want to do that. Hey guys, if you don't follow GLG Knife Works, go follow GLG Knife Works. John does some really cool stuff in the knife making world. Anyway, we got this working, and that really cool mirror-like finish was a result of the wheel goes over and it dresses itself using the so-called rough settings that I give it. Then it went and did the rough grinding, which was not that rough, but it was sort of standard. And then it comes over and does a fine dress. So the fine dress is the same depth. I cut a 0.5 No, I take it back. The rough dress is 1,000th. The fine dress is 0.5, and I slow it down a little bit. I slow the dress across the wheel a little bit, and then I go do that fine grind. And the results, as they say, the results speak for themselves. It was pretty spectacular. So I don't want to do this all the time because it's not necessarily Roger that, John. It's not necessarily what you need for a particular part, but it's nice to know you can do that and then come back to it. So that was pretty exciting to get that going. And this is A2 tool steel. So we've done some soft steels. The big offset plate, which I can show you that. I got to put the phone in a holder. And what do you know? So you're being held in a grinding vise, which I think is very appropriate. Oh, man. So here's the offset plate. We're getting, again, ridiculous finishes, and this is soft steel. So this I had originally, when I was developing my recipe for this offset plate, we tried case hardening it, and it warped. And it warped more than I liked. So I was a little bummed about that. So I actually ground out the case hardening, top and bottom. So you're looking at soft steel here, but the edges are still hard, which is kind of funny. It doesn't matter. So this guy came out great, and of course, I posted this. No job is complete until the laser work is done, and we put the laser mark on here, and you cannot feel this mark. That is, it's called they call it annealing. I call it oxidizing, but this is the equivalent of bluing, or oxidizing on a steel part. And if you get your laser parameters just right, that's what you're able to do. I'm also able to engrave, but that's not what I wanted for obvious reasons on this. So very happy results on this guy, hard tool steel. Very happy results on that guy. And we're going to make stones this weekend. So if anybody has any questions, I will be happy to entertain them. Use the question button at the bottom, and I'll try to get that answered. Anybody want to guess what those little buttons are for? I should probably go back there because there's some people who joined late. I was on the lathe last night and this morning to make some parts. So here are those parts. Thank you, sir. Appreciate it. So these are these little buttons, and my only hint to you is that they go to a different department. So if you want to guess what those are, I will give you the answer if somebody guesses. That was after Op 2. This is after Op 1. How do you dress for the... Oh, that's a good question. Hang on, I'm just cleaning my lenses here. I think I put my fat fingers on them. So PFG stones are ground with a metal bond. Here, let's go take a look. I've discussed this before, what wheel we use. So this is from Continental Diamond, and this is a metal bond diamond wheel. This is a $500 wheel, by the way. They don't give them away. And welcome, Bjorn. And this has the Renzetti modification on the hub, which is very useful and saves time and anguish on diamond wheels for reasons I won't deal with right now. But anyway, so we dress this guy, and we use a molybdenum dresser. So this is a stick of molybdenum held in a chunk of 4142. Pretty exciting stuff. You could do it any way you want, but we dress with the molybdenum. We take a 2/1000 deep dress at 1200 RPM on a 7-inch wheel, and we go. So we get about 75% with those numbers. We get 75% dressing efficiency, which means if I take 2/1000, I take 1/1000 and a half off the wheel and a 0.5 off of the molybdenum. And you cannot do this at fast grinding speed. Okay, this has to be done slow. If you read the patent by Werth, W-E-R-T-H, he talks about it. So it turns out that for my wheel size, that's about 1200 RPM, and the wheels are normally grinding at about 3000 RPM. So that's how we dress. We dress with this guy, and it works great. And as you can see, this is a consumable. I bought a big stick of molybdenum, and it'll take me my lifetime to go through it. And if there's any interest, I can make. I was thinking of turning this into a product, a great question. Am I going to add that for the automatic dresser function? So let's talk about that for a second. Let me get rid of my shield here. So, yeah, I want to put the height of these diamonds is about 1/10 of an inch below the surface of the chuck. So and you actually give the software the distance from the diamond to the edge of the chuck. So it actually, I haven't proven this yet, but it knows about the edge of the chuck. So it will not, if you do something dumb, it's not going to grind into the chuck while dressing. I'm sure if you're brilliantly dumb, you could figure out a way to do that. But anyway, so you see that hole right there? There's a threaded hole there, and I believe I can design a block that'll hold my dresser about there and attach it to the table and put that right in the magic line. And I believe I can do that. There are some issues with that, okay? One of the issues is, I see a question came in. I believe that the software in the machine thinks that diamonds don't wear, okay? And of course, this isn't a diamond, but it's the same thing. So this definitely wears. So I am not 100% sure that I could figure out how to do it in reasonable time. So that's a super good question. I'm going to try, and I will report back. But we have a couple holes here for doing stuff, or I could mount it off of this dresser and just modify this, which I have no problem doing. You'll also note that this guy, there's a riser here. This is a 15 millimeter riser that you have to use to get high enough when you're using this chuck, and that comes with the grinder. So it's not like they didn't anticipate that. So that was all in the kit. So excellent question. And is there ever a time where a super shiny grind finish would be undesirable? Yeah, that's a really super good question. Thank you, Chris. Yeah, a super shiny grind like this would be undesirable if, for example, you expect the lubrication on sliding parts to have a place for the oil to be captured. If you have two sliding parts that are this shiny, they can stick. And I don't mean ring, because ringing is also a possibility, but they can literally get on a chuck, right? Well, I have to say that while I did not get a mirror finish on my chuck, the chuck is pretty smooth, and it's smoother than my last chuck. And getting parts off, not from magnetism, but from hydraulic suction, is pretty amazing. So yes, it's sort of nice to have a little bit of roughness on the chuck. But that is a good reason not to have it, is because you can get adhesion between the super shiny part and between two super shiny parts, right? If you have a super shiny part and like a not so shiny part, the chances are that they're not gonna stick to each other. And I don't have two super shiny parts to show you here. I just have the one. So, and what's amazing is I did not scratch this because it's nice and hard. Good question. I hope I answered it. So, but here's the thing: if you don't have the capability of doing that, you haven't gone past, where you might need to be operating. It's hard to kind of dial in a process that's what you want. It's nice to know you can do overkill, because some people think that the best kill is overkill. So now that we know we can do overkill, we can dial in a surface finish that we want, which to me is just magnificent. Excellent question. Hey, you're welcome. So coming soon is putting this guy to work. So this guy, what an offset plate is, the offset plate sits on the chuck. I'm not going to lift it because I can't do it with one hand. The offset plate sits on the chuck at 90 degrees to the chuck, and then you could mount things on it, like a rotary. Hey, surface grinder class. Yes, absolutely, Indiana John. So we mount a rotary jig or something on the offset plate, and we have the offset plate gives us working room this way. Plus it has the screw holes, and the screw holes on the offset plate, they might look, if you use any Suburban tools, this might look familiar. This is the same Suburban tool pattern. So my Suburban tool master grind will drop right on here and screw down to this pattern, which is pretty awesome. Plus, you could do other things with this. Anytime you think you need a screw down surface, there it is, and you can put this on the chuck sort of the normal way. So I hope that answers the question. So that guy is going to get to work soon. I do have some rotary grinding parts I need to make. One of them is the balancing arbor for the balancing jig that some people are patiently waiting for. The balancing arbor, I'll show you what it looks like. There it is. So we're going to grind that surface that goes into the chuck. So we could use two different parts, put them together, and then once they're together, we can grind that surface, and that'll make the arbor. So I'm working on doing this in a very economical way, so that we can sell our balancing stand for a decent price. So there you go. So that's the rotary project coming up, and that's one of the main drivers for getting the offset plate done, and it's done. So I'm out of excuses except for time. Excellent. So once again, if you have questions, hit the question button on the bottom, and that way everybody can see it. So that's what's been going on here. Yesterday it was super nice out, and I had the doors open. That was really pleasant. Today it is raining. I have a J&S grinder that still needs some work, but will run soon. First time using a surface grinder. Any advice on coolant? Yeah, I use a lot of it. So this is my coolant setup. It's a. I know this won't be your coolant setup, but just to make the point that more is better. I suppose there are some places where, again, I don't consider myself an expert on grinding, but there are some places where you don't want coolant. I don't exactly know what they are right now, because I want coolant all the time and tons of it. So this system works great. We have a coolant pump that comes down. I posted this, but if you didn't see the post, this came from the factory with a valve for the schnozzle, but straight in. And when the CNC control turns off the coolant pump, the coolant would suction back up and leave a bunch of air in the line. So for $12, I put in a check valve from McMaster Carr. I think I posted the part number for this. And now, as you can see, the coolant is staying put. And that was worth the price of admission right there. So when the coolant pump goes off, the coolant just stops. And when the coolant pump turns on, the coolant is going. And that was a huge improvement. The other thing you need to know about coolant, of course, I think you know this, you have to pick a coolant. So I am running Qualichem Extreme Cut 250C, nominally at 4%. And I say nominally because I don't care if it goes down to 3% or even a little lower. You don't want to get too low because then you run the risk of corrosion. Oh, and the other part of my coolant recipe, and this is very important. Let's talk about coolant. I use all distilled water. Now, distilled water is just water, and that's what I want. Because what happens is if you use tap water or well water, and I've been burned by this, when the water evaporates from the coolant, you end up with a concentration of whatever was in your water. If you had any chlorides in your water, you are going to get corrosion. If you have any minerals in your water, you're going to get the possibility of the coolant not performing properly. I can't get too specific on that because I'm not smart enough, but I use all distilled water. Now, there is a pernicious rumor out there that if you use distilled water with coolant, somehow that's bad. Okay? All right, here's the stuff. There's this pernicious rumor that if you use all distilled water, that's bad. I'm here to say, and we're all adults here, that is unmitigated bullshit. So, the reason you hear that, or the wives' tale started because, and this is my theory, I haven't proven this yet, is that coolant manufacturers add additives to the coolant in order to accommodate city water or tap water, water that's going to have minerals in it. So once they do that, they're saying, hey, we designed this coolant to be mixed with tap water, mix it with tap water. And if you mix it with distilled water, and then I think the erroneous conclusion was, if you mix it with distilled water, something bad happens. Nothing bad happens. So my CNC mill, which we're sitting 20 feet away from, has 42 gallons of the same coolant, except that nominally kept at 7%. It's mixed with distilled water, and I have not touched that except for adding distilled water and topping it up. I've been running it 10 years. 10 years. That coolant is awesome. It gets filtered, and the filtering naturally aerates it every morning, half an hour to an hour. I think I have it set to an hour. The pump runs, and then the pump turns off. And we have a Keller. We have a Keller coolant cleaning system, which removes oil and also runs it through a filter, and also has a settling tank so that any heavy stuff settles out. And we've always had that Keller system. And there's other systems, but back when I started, it was Keller filtration. So between the Keller filtration system, the use of distilled water only and always, and a coolant that I think has been superb, which is Qualichem 250C. I have never had coolant problems since then. Now, I had coolant problems before then, and I'll tell you a little bit about that. So, Indiana John wants to know, does using coolant help prevent warping? Yes, absolutely yes. Because warping is caused by heat input, and if you're using coolant, you're reducing heat input to the part. So it will help. I shouldn't say just heat input. It's caused by stresses, which uses the heat input to put a stress in. So yeah, a coolant is very good for that. So before I started using the recipe, I just outlined for you. I wasn't smart enough. I wasn't knowledgeable enough about coolant, and I used another coolant. Well, I'll tell you what it was. I'll skip that. I used another coolant, and I used my well water. I lived at a different location, not this location, and I had corrosion issues, and I was really bummed. Imagine having your brand new CNC machine, and after a couple of weeks, you could see some spider corrosion on some of the metal surfaces. I was not a happy camper. So I did a lot of research and lab testing. I have a very, very good water lab about 10 miles away, and I found them. And the guy who owns the place was a water scientist. And we started looking at this problem. Hang on, I'm just reading your... So this water scientist and I looked at the problem, and we figured out that it was very low levels of chlorides in my water, which may have come from road salt from a nearby road, was getting into my well, and that was causing corrosion issues. So I immediately started using distilled water for everything after that. And we'll talk about bacterial growth in a second. And I've never had a problem since. And it's not expensive. So if you go to the supermarket, we could buy a gallon of distilled water for under 50 cents. I mean, it was very inexpensive. So I have a still in the basement. I have a 1 gallon mega ohm still, and we just make distilled water all the time and store it in jugs down in the basement. So that has been a huge win, and I strongly recommend distilled water. RO water is also good, except RO water wastes a lot of water. So you have to decide if you want to waste a lot of electricity or you want to waste a lot of water. You pick the one you want. But so you said the only thing the only thing about tap water I've heard is that some coolants will bond a little better in large batches, otherwise distilled. So here's the thing. I've heard all the arguments. I've heard if you always use distilled water, you're always using the same thing. Distilled water is distilled water. H2O, nothing else. Have a nice day. So as soon as you say I'm going to use tap water, the words tap water means I have no idea what's in my water. And tomorrow it could be different. And with well water, it's the same thing. You could measure what's in your water, but is it going to be the same in 3 months? So we don't need any of that nonsense. Use distilled water. If you think I'm up on a soapbox preaching here about distilled water, that's because I am. It's one of my hot buttons. So distilled water, always, all the time. And take care of your coolant. Filter it, skim it, talk nice to it, feed it dinner, and it'll treat you right. Now, bacterial growth. Let's talk about bacterial growth in coolants. How do we get on coolants today? I'm sitting in front of the grinder. So the number one, there's two kinds of bacterial growth in coolants. Well, it's probably a bunch of kinds, but there's, and this is going to be controversial, but there's the good kind and the bad kind. If you talk to or read about Qualichem or any of the coolant manufacturers, Qualichem I know for sure, they actually want a certain kind of microorganism in their coolant, because it's the microorganism that eats the bad microorganisms, and that is an aerobic bacteria. I'm not an expert in that stuff, so I can't tell you what it is. But when you get coolant that's stinky, like that is an anaerobic bacteria, which means it does not want air. And if you have a coolant, if you have oil on top of your coolant, and you have this bacteria in your coolant, and it's stagnant, you start growing this stuff. And then the first day you come in on a Monday, and it smells like something died. That's the anaerobic bacteria. Nobody wants that. So if you filter your coolant on continuously or on a scheduled basis, I do a scheduled basis, and you keep the coolant moving, that's excellent for aeration. Okay, so you're getting rid of the oil, which is good for keeping away the anaerobic bacteria. You're exposing the coolant to oxygen, which is good for keeping away their anaerobic bacteria. And you're using an excellent coolant like Qualicam, which is already engineered to keep away the bad bacteria. So if you do all those things, you're going to be all set. If you don't do all those things, I can't help you, buddy. All right? I hope that answers some coolant questions. But that's my coolant philosophy. And I know there's a whole bunch of coolant hype out there. If you get down to super exotic materials, you need to really pay attention to what coolant you're using. There's nothing super exotic here except for, the operator. Anyway, any other questions about anything at all? It's already 12:41. You guys are awesome today. So I know nothing about coolants. Do you have any recommendations for milling titanium and surface grinding heat-treated high carbon steels? So I surface grind heat treated high carbon steels. I just showed you some, and everything I just said about coolants applies to that. Then you go and you bring up titanium. Okay, I am not a titanium expert. Don't know anything about it. Titanium is quite reactive. And it may require some different coolant. I think if I was doing a bunch of titanium parts in my shop, if this was a titanium shop, I might be very cautious about mixing my coolants with the titanium stuff and the non-titanium stuff. Again, I'm not an expert. Would I put titanium like on my grinder and use my coolant and my coolant system? Absolutely, I'd have no problem with it. I'm not doing it on a production basis. But if I was doing titanium, like that's my business, I would talk to my coolant people and see if there's anything special. I could be wrong. Maybe you could mix and match. I don't know. But I do know that titanium raises the flag, and you have to, identify the right thing to do. I am not a resource for that. No titanium. Well, no significant titanium here. Sorry about that. Good question, though. Any other brilliant questions or lousy questions? I don't care. So, one of my philosophies of engineering in general is that the most valuable thing you can say is, I don't know. I have fired guys over, not in my business, but people who were service providers to me, because they were unable to say, I don't know. They would just continually bullshit me, and don't do that. If you don't know something, say, I don't know. And the second thing that comes after that is, but I will find out, and then go find out. So titanium, no sabe. Anyway, what else is going on? What's going on with you guys? Who's in the shop today? That's what I want to know. Who's making stuff in the shop? So, hey man, awesome. Thanks for hanging around. I used the wheel that came with the machine. What other wheels do you use for steel? Any advice? Oh, you're in the shop. Good. And you're grinding. Oh, Adam's grinding. Excellent. I'm going to get to your question, Bart. Well, feels like you're kind of up to your eyeballs in the whole grinding thing, doesn't it, Adam? It's toasty where you are, huh? We got nice, cool weather, and it's raining. And if we had stuff going on, I might even have the doors open with the rain. Just one guy fixing the truck. Excellent. I'm coming back to the wheels question. By the way, guys, we do have Adam the machinist amongst us, and if I say anything stupid, he has complete permission to whap me upside the head, because Adam knows more about grinding in his pinky than I will know in the next 20 years. Okay, so let's talk about wheels. So first, the the wheel that came with the grinder is kind of like the it's kind of like the refill that comes with the pen. It's kind of like the any thermal concerns in winter or summer. We'll talk thermals. Okay, so let's talk wheels, then we'll talk thermals. So it's kind of funny, but it's a good wheel. It's fine. I recognize it for what it is. It's a white wheel, and they want you to be grinding when you get your grinder. So I like, all right, I'll use it up. No problem. It also came, by the way, I know we're not talking about this, it came with a very interesting adapter. So this actually has a 3-weight balancing thing on the back. This is a balancing hub, which is interesting. So do you think I checked the balance of this before I put it on the grinder? You bet your sweet bippy I did. So this guy was balanced, and they did a good job, and they put a little ink on the screws, like, this is balanced, don't touch it. Okay, fine. But it actually was. It was fine, balanced that way. So use it up. If you are just getting into grinding, the good old white wheel will do 90% of what you need, maybe more depending on what you're doing. So believe me, there's more parameters that you have to worry about than the fact that your wheel is white. That's another pet peeve of mine. Well, not a pet peeve, but just sort of a hot button that all the manufacturers, pick cool colors for their wheels as if the color matters. It's not the color, trust me. So let's see. Let's look at wheels. So this is a white wheel. This is a white wheel. And if you look down in here, these are dressing wheels, but they're also white wheels. So when we say white wheel, we generally mean, hey, Indiana John, do me a favor. Use the question button. I see what you just said, because I'm going to lose your question. It's going to scroll off by the time I'm done talking about wheels. So the white wheels, again, will do most of what you need. They're inexpensive. They get the job done. They come in all sorts of grits. Mark your wheels, because all the manufacturers put this nomenclature on the wheel, and then as soon as you put your adapter on it, you can't read it anymore. So you have to, you kind of have to work around that. You can see I marked everything so I could read it. So these are called these are Norton 38A. That's the standard white wheel. And again, this is going to do you 90% of what you need to do, especially if you're just beginning. This is aluminum oxide. Okay? Remember that. This is aluminum oxide. That's what white wheels are. So then we come over here to another Norton. Oh, no worries. It's just we have to manage the questions, or else you think I'm ignoring you, and I'm not. So here's another wheel from Norton, which I like a lot. This is a 32A. This is, I don't know, you call it the blue wheel or purple wheel. You're hearing this from a colorblind guy, so I don't know. Anyway, this is a good wheel also, and this is a little more rugged than the plain white wheel. Another very good general purpose wheel. Can't go wrong. But there's the nomenclature, 32A, 46. IVBE. 32A is the wheel type. 46 is the grit. I is the friability. Yeah, blueberry. There you go. I will never call this anything other than a blueberry wheel. Thank you very much. And then I is the friability, and VBE means vitrified, and BE, I don't remember. BE, actually one of those letters has to do with the openness of the wheel. 32AA is another one. Okay. Anyway, there's a bazillion wheels out there. But either one of these guys, 32AA, either one of these guys is a very good general purpose wheel. Then you got to start getting into some other things for other applications. This is a green wheel, or so they tell me. So this is also a Norton. Let's see. Boy, I can't read it. But this is a silicon carbide wheel. The industry standard is green is silicon carbide. I think that is an easy choice. Silicon carbide is a different chemical, right? Different grain, used for different things. 39C. Thank you, Adam. I appreciate it. So this is a 39C if you're in the world of Norton. The grain is sharper, but it's weaker and it's harder. So if you're going to grind, for example, hard cast iron, this is the wheel. It's good for. I'm not going to get into the deep dive here, but it's good for certain corner cases. In the old days, before diamond wheels were easy to make, carbide was ground with green wheels, and so you can use a green wheel on carbide. I know a lot of some of the exotics can be done on carbide. You can also grind aluminum with carbide. I'm sorry, you could silicon carbide. You can't grind aluminum with, well, you could, but you're going to get into trouble with aluminum oxide, because aluminum is aluminum oxide. You have a chemical similarity, and that leads to badness. Great for red metals also. Oh, good point. Yeah, if you're doing bronze, the green wheel is your buddy. Thank you, sir. Diamond wheels. Of course, I told you about this guy. This is a metal bond diamond wheel. This guy here is a resin bond diamond wheel, and I have a couple of different flavors of those. These are affordable at about $120 a wheel. By the way, these white wheels are about $35. So just to give you an idea. Then we come over here, and you hear about the ruby wheel from Radiac. I bought this. I was intrigued. Solid Rock Machining uses these a lot, and they're very open. You can see that. So these are pretty cool. And this guy is a 46, and the number at the end is about the openness. Yeah, Steve Barton, exactly. So I bought it. Interesting wheel. It's still aluminum oxide. There's some ceramics in there, but basically it's still aluminum oxide. This is one of those things. It's like, ooh, it's ruby. Well, even rubies, like literally the gem ruby, is aluminum oxide. So, don't get too excited. This wheel is very interesting. So I did a little bit of hacking for Mr. John Grimsmo, and we used a couple of different wheels to see what would be a good wheel for his blade steel. And this is a pretty nice wheel. This is called a 5SG wheel from Norton. And this was recommended by Norton for stainless steels. So this is pretty neat. So 5SG is the wheel type, 46 is the grit, I is the friability, V is vitrified, and S is for Spencer. Just kidding. There you go. All right, we have questions in the queue, and it's getting to be the top of the hour. Let's see. Chris asks, can you call this chat Sundays with Spencer? Yes, I can. Adam the Machinist asks, does the nib really need to be on an angle, or does offsetting the wheel in X accomplish the same thing? Adam, of course it's a setup, because he knows the answer. Yes, that's right, Indiana John. You heard it here. Tell the world you heard it here. All right. So let's go back to the grinder for a second, because Adam asked this awesome question, which is he already knows the answer to. Let's see. Boop. So there's the diamond, and you'll notice it's canted at probably an 11-degree angle. And the wheel comes across that, right with its center line right on that diamond. And Adam says, innocently, does it need to be on an angle? Or can you come over to the wheel and just offset your very straight vertical diamond and achieve the same thing? Hang on, let me grab a diamond and show you this. What a great question. Because I have something to say about that. So this is a little diamond, by the way, that I made out of a mag switch. So here's the diamond, here's the mag switch. So I can go over to the work that I'm working on, and I could put the diamond on the work to dress, and that's why I designed this. So this guy's straight up and down. So it's not canted at the recommended 11 degrees. So theoretically, I shouldn't have it right under the wheel. But if I move it over approximately 1 inch, it's actually a little more than 1 inch, but if I move it over 1 inch, look what happens. I get my magic angle. So I do this all the time. I use this all the time when I need to use a manual dressing, right? Which was always until that guy came along. So I always came over, and I just let me clutch my wheel here. You just offset the diamond, and boom, go to town. So you could use 1 inch to the left. Never go 1 inch to the right, ever, because of this. All right, 1 inch to the left of center, and dress your wheel. And that'll work great. And this is one of my wheel dressers. I didn't think we're going to get into show me your wheel dresser a day, but and the other one, this is one I used for a long time. That's my most used wheel dresser ever, and you can see how complicated it is. It needs no explanation. But that's my trick. I move 1 inch to the left. And that number is for 7-inch wheels. Hey, C. Snyder's 1976. I have no idea who you are, but welcome aboard. So there you go. Excellent dresser question from Adam. Very good teaching point. Let's see. We had a machining question here. Any tips on turning threads 632 right up against a shoulder 3/16? Ideally, I'd like to roll them. I always put a relief in, so you're asking the wrong guy. I would always put a shoulder relief in, even if it's small. You also might. Okay, let me go over to the lathe. If you guys tuned in for all grinder all the time, I apologize, but we actually have to talk about, lathe. So where's my lathe? Okay, so here's so there's a threading tool, right? And you could tell. Let's see. There we go. you could tell that I can't focus. You could tell that the threading tool, you're not going to be using that whole V, right? So you might have to modify a threading tool to get up tight to that shoulder, but you're never going to get perfectly up to the shoulder. That's an impossibility. So I always put a relief in, but you're going to need a modified tool. So that's all I can tell you. So sorry that might not have been a satisfying question or a satisfying answer to your question. All right, let's see. I think we got that one. I think we answered all the questions, and I think it's 1 o'clock. So, in the interest of not going on forever here, this was a busy one today. I think it was raining for some people, and maybe that's why you showed up. Hey, I hope you had fun. Maybe even learned something, or maybe I learned something too, which is the best part. And we'll see you guys. I guess we'll see you next week. Sorry for the late notice on this one, but just, expect it. So from Kinetic Precision, this is Spencer saying have a great day.